Hello and welcome to the Chirp Science. I'm Andrew Michaud, and today I'm here with an adjunct professor of physics and one of Keene State's resident astronomers. Would you like to introduce yourself?
Yes, I'm Keith Goodale. I'm an adjunct professor here at Keene State, teaching physics and astronomy.
All right, where did your interest in physics start, Keith?
Actually, astronomy is a branch of physics. So when I was a child, I used to go out and I used to look up at the night sky, and I always wondered what was up there. So I began to look, and at some point I realized, I should learn some physics. So it really started with astronomy, at a young age.
Very cool. So you take some great astrophotographs. You sent me a few, actually. Do you take any non-astrophotographs?
Not really. I mean, I take, a picture here and there or whatever, but I'm not a photographer by any means. So when I started taking astro photos, I had pretty much no experience. So I started from the astronomy and worked my way into taking the astro photos. Okay. And I still don't take any regular photos other than maybe on a phone or something here and there quickly.
Okay. So. All right, so you did actually send us some of the astro photos you've taken. So if you want to turn your attention to the screen there, we're going to bring a few of them up. And if you could tell us a little bit about them as they come up.
Okay, so this is the Lagoon Nebula, in the constellation Aquila. And if you look at this picture carefully, in the center, it's kind of hard to see here, but the Hubble deep, sky field view, where you see the pillars of creation.
Oh, yeah.
Okay, this is that region, and you sort of can see that in the picture there, but it doesn't have the type of detail that the Hubble does. Also, the colors, because of the camera, are different from what the colors in the Hubble image are.
Okay. Is that a common occurrence, like different equipment picking up different colors for celestial bodies?
Absolutely. That the eye sees things differently than a camera would, and depending on how you take the picture, the equipment that you're using, filters that you use, it's going to look different in terms of the colors. For example, if you typed in like something common like the Orion Nebula, and you looked at all the different images that showed up on, the web or whatever, you would see a huge variety in terms of the different colors due to the different equipment and filters and exposure lengths.
Now, is that purely an aesthetic difference in the pictures, or does that actually change some of the scientific results you can see if you have equipment giving you different colors?
Partly it's aesthetics. There is some science there that at some wavelengths of light, there's objects in space that emit light naturally at those wavelengths or frequencies, or in other words, colors. So you might be using equipment that is tailored towards that light to pick up what's coming out or coming from that object for that reason. Okay, so there is sometimes a science reason why you would see a certain color.
Okay.
So.
All right, very interesting. We have a few more.
Okay, this is a binary star 61 Cygni. It's kind of historically important because it is the first star ever to have its distance measured. And it's kind of interesting. It is a relatively nearby star, something like, I think it's around 11 light years or so, something like that, away. So if you went out and you photographed it every year with background stars, you could actually see the motion. Okay. In addition to that, these two stars are in orbit about one another. It was actually a fairly easy shot because it could be a short exposure because the stars are fairly bright there. And another thing to note is you can see some color there also, kind of a yellow gold color that tells you something about the surface temperature of those stars. So,
is that a particularly hot star with that color?
No, actually more cooler. When stars tend to be bluer, they tend to be hotter. And as you work the opposite way towards, yellow, red, they tend to be cooler. So.
Ah, okay.
Okay, so this is the Andromeda Galaxy. This, from a technical side, I took a little bit differently than I think most of the other pictures. Usually there's several telescopes working in conjunction when I'm taking an image. One is actually taking the actual image. The other is tracking the object because the Earth is rotating and you're doing a long exposure and you want to track. What I did on this one to get a larger field of view is I switched the two telescopes. So this is a smaller telescope, but it's a wider field. And it's actually a pretty long exposure. I think it actually was a couple hours.
Oh, wow.
And then afterwards, when you do these photos, you have to process them with software afterwards. Otherwise, they look different from what you see there. And that one there was actually quite a bit of work to process. I bet I probably have about 50 hours between the exposures and the time processing for that one there.
Wow.
So, yeah, that was quite a photo. That was a long process.
So is that like working with it in like Photoshop or something similar to that?
Yeah, Photoshop and some other programs. And actually, I think I did ultimately do most of the processing in Photoshop, but there's other software that's dedicated for astrophotos specifically. Okay. So I probably used like two or three different programs when I did that. It was a couple years ago, so I sort of forget. But
all right, very cool.
Okay, so this is a Galaxy NGC 891. This is one of my favorite galaxies here. We're kind of viewing it from what we would say edge on. If we could see it rotated about 90 degrees, which I think I have another image in here that would give a view of it if it were rotated. It'd be more a disk and it might have a spiral structure to it, but we're seeing it kind of on the side. And you can see in the center there is a dust lane coming down. So I like this galaxy here. It's a tough one to see visually, but it's one of the ones I like to track down visually too, because it looks kind of like a needle in the telescope visually, and you sort of can see that here a little bit.
So a few questions about that one. You said it has a dust lane. Could you define that?
Yeah, I mean, there's a lot of gas and dust in galaxies, and the regions that are glowing are going to be like gas that is basically glowing in some of the lights from stars, and that dust in there isn't going to be glowing at visible wavelengths. So if it's in front of like those stars and any of the glowing gas clouds or whatever, it's going to obscure it, and you're going to get dark regions like that.
All right. So that photo there looks much farther out than the one of Andromeda. And correct me if I'm wrong, but Andromeda is our closest neighbor, correct?
No, there are galaxies that are closer, but it is one of the closer galaxies. It's part of what we call our local group of galaxies. The Milky Way, our own galaxy, is gravitationally bound to it, and we're about, we're in orbit with it. And actually give ourselves like a few billion years, and we are actually going to collide with the Andromeda galaxy. It probably won't be as devastating as it seems, because really there's a lot of space in galaxies. The stars will mostly miss each other. Maybe a few might collide, but hardly any considering the number of stars. Any gas and dust that's left over will interact, and the galaxies will eventually spiral together and merge and become a larger galaxy. So that's kind of our astronomical destiny, in a few billion years.
Huh, interesting. So what does that mean for like a solar system? Would that like double the amount of planets we have? Would that?
No, I mean, boy, how the solar system would be affected, it's hard to say, because like I say, there's a lot of space between stars. So stars, it's unlikely they're going to, collide. Like I say, it can happen. There probably will be some. I'm sure there will be some. There probably would be some gravitational interaction that might disrupt things in the solar system. But the thing to remember, that far into the future, our solar system is going to be a much different place. The sun will have evolved from its current state, and it's going to be much larger by that time. So I think the bigger thing for the solar system is going to be the sun aging, and this would be something to worry about after that and further down the road. So
Very cool.
okay, so this is the Lagoon Nebula. This is in the constellation Sagittarius, my personal favorite constellation. And basically what it is a cloud of gas in space, largely hydrogen, maybe a little bit of hydrogen, helium mixed in with that, but pretty much mostly hydrogen. And out of the hydrogen gas, young stars are being born. And when young stars are born, they're hot, they give off a lot of ultraviolet radiation. And that ultraviolet radiation interacting with the hydrogen clouds causes it to glow. And it gives off this nice, reddish pink color on the camera that I actually use to take it. Because like I say, take it with different cameras, different filters, it will look different. And by eye, if you look at it, you can see it with just your eye. It's better in a telescope. Your eye isn't sensitive enough to pick up on the colors, so you typically see a grayish color through a telescope.
Oh, okay.
Okay, but those are hot, young, glowing stars that are illuminating the gas, kind of like a neon sign would glow.
Oh, very cool.
Except for it's hydrogen and not neon.
Okay. So you said Sagittarius was your favorite constellation. Is there a reason for that, or?
Yeah, a couple of reasons. One, if you look at the constellation, the brighter stars make up a shape. Makes the shape of a teapot. Usually when I look at constellations, and they're supposed to be some type of figure, shape, or whatever, I don't see it. This is one constellation where I can actually see a teapot. And we call that an asterism, those groups of stars that make up shapes within a constellation. And what's more interesting is the Milky Way runs through it. And where the spout of the teapot is, the Milky Way looks like it's steam coming off the teapot if you're out on a dark night.
Oh, okay.
And since we see the Milky Way, we're looking kind of in the plane of our galaxy, actually towards the center of our galaxy. And what that means is there are many objects, interesting objects, in that direction. So I can spend, an entire night from dusk to dawn with a telescope, if Sagittarius is up, just exploring within the constellation. So not only does it have that cool teapot shape in it with the Milky Way, it just has tons and tons of telescopic objects to view.
Oh, awesome.
And that was one of them that we saw, the Lagoon Nebula.
Excellent. Familiar with that one.
Okay, yeah, that's the moon. And in some ways the moon is a little bit easier to photograph than the other stuff. You can do typically shorter exposures. It can be tricky too because you can overexpose it. You can even underexpose it. But that was a quick shot. But once again, there's processing. It wasn't Photoshop in this case. It's something called Registatics. And trying to think, because it was a while ago. Actually, what I think I did use the Canon 6D camera, but I used it kind of almost like I was taking a movie by taking rapid pictures in succession.
Oh, okay.
Okay. And then I put all of those in the software, and the software pulled up the best of the pictures and stacked them or combined them, and then I tweaked all the details to bring out the detail that you see there. So if you look at the top, you can see like the cratering and some of the mountain ranges and that stuff. And that's partly, it's really there, but the software really helps bring it out.
That is an incredibly clear picture of the moon.
Yeah, it came out pretty good.
Oh, it's very impressive.
And part of that, like I say, is the computer taking the best images and saying this is a sharp one, this is a sharp one, and then combining them.
Very cool.
Okay, this is an open star cluster, and this one, I don't know what it is. I did when I took it, but what happened was I didn't label the file, and I didn't process it on the computer until quite a while afterwards. I think I found it like maybe a year or so later after I took it. And it came out when I processed it. There's some things I see there that I don't like about it that I could have done a better job with, but I think it came out pretty well, and the colors came out pretty well. So I really like the photo. It's just I can't remember what it was because I didn't label it when I did it. One of these days, there's something called plate solving where you can put photos in, and it's on the internet, and it can actually identify what the stars are and tell you where it is. So I'm going to run it, have it plate solved one of these days, so I do know actually which star cluster it is.
Oh, very cool. All right.
Okay, so this is a spiral galaxy. This is the Whirlpool galaxy. This is what I meant when I was talking about the edge-on galaxy before. If it were tilted 90 degrees, you would see a different type of structure, possibly a spiral, likely a spiral, something like this. So yeah, if we rotated that 90 degrees, we'd get a galaxy that from Earth looks like that. And then if it were rotated back to the Whirlpool galaxy, you'd see maybe something like that with the spiral structure.
Oh, okay.
Okay, so this is a common type of galaxy here. There's different types of spiral galaxies, and then there's galaxies that aren't spiral galaxies like elliptical. But these kind of are some of the best because they have that interesting spiral pattern to them. And actually, I'll note here, there's actually two galaxies there.
I was just going to ask about that.
Yeah, if you look at that outer tail, it ends, and it looks like you sort of have a bright nucleus or knot there. These are two galaxies that have run into each other and are currently interacting, and they're sort of passing by each other. So this is almost a pretty good example when I was talking about the Milky Way, our own galaxy, and the Andromeda galaxy, what our destiny is going to be. It might be something similar like this.
Oh, very cool. All right, and I think that's it for the astrophotos.
Okay.
Speaking of telescope photography, you're known around campus as one of the professors that sets up a telescope for people to stargaze with. What inspired you to start setting up on campus like that?
Oh boy, it was many years ago, and I think how it started is a professor who was teaching astronomy. Since I was fairly knowledgeable in astronomy, I was only teaching physics at the time, but he knew I had telescopes and knew my way around the sky pretty well. He asked me if I would want to come to his observing sessions, his essentially night labs for the students. So that's I think how it started for me. So I started helping him out, doing his observing sessions for his students, and we typically would do them up in Westmoreland under darker skies. But because that's one thing here on campus, you have all the lighting from campus and plus the city of Keene, so it washes some of the stuff out, but not everything. So for things like the moon, it doesn't matter. Bright planets, some of the brighter deep sky objects, you can set right up on Appian Way. And not originally my idea. There's this idea of people who are sidewalk astronomers who set up on sidewalks in cities. I just copied what they did. And we started doing that and said, hey, why don't we do a moon session or a planet viewing session, and just impromptu, I would, just pull telescopes out on Appian Way, when it got dark and, catch all the foot traffic.
Have you been able to continue that with COVID around?
Yes, we have. The first semester where we had COVID and we went remote, obviously, no. We couldn't do actual in-person observing. And then when we came back, we started doing it. We limited the number of people that could attend. Masking was required. We would socially distance. And actually, in conjunction with one of the other physics professors here, Professor McGregor, we would hold sessions. And we would hold enough sessions so all the astronomy students could get some viewing and do a night lab. We did have the restriction, only people in the class. We've loosened up. We're not holding it to a certain number now because we, at least coming into the semester, we were in a little bit better situation. More people vaccinated or whatever, but and we'll see whether we can continue to do it over the summer. But yeah, we've been doing fairly large sessions, specifically for the astronomy students, but some of them are bringing friends. We are planning an impromptu, which we will announce via email on campus. We're going to do something on Appian Way one of these nights coming up.
Okay.
For everybody. And we'll do that a couple times this semester, too, out there. Okay, so
that will go out to all students' emails when that's happening?
yeah.
Oh,
Yep.
excellent.
Yep, and then we'll catch anybody who's just passing by also, so.
Oh, very cool.
Yep.
All right. So you sent me some papers as well before we talked, and I see that much of your work lately has involved binary and double stars and studying their positioning. Mm-hmm. So what is the difference between a binary star and a double star?
Okay. If you look up at the night sky, and let's say with a telescope, if you look in the telescope and you see two stars that are close together, they're a double star.
Okay.
Okay. Now, they may just happen to lie along the same line of sight that you're looking in, and one may be very far away, and the other may be on a relative scale, somewhat near Earth. But they just happen to be lined up, so they look like they're close together. In other words, they're not gravitationally connected.
They don't influence each other?
Right.
Okay.
If they are close enough, they could be a true binary star where there is a gravitational interaction. They orbit about a common center of mass, so they are physically connected by gravity and orbit about one another.
How common is a binary star?
Extremely common. The sun is an exception. Okay? Majority of stars are at least binary stars. Some are triple star systems. There can be quadruple star systems. But most stars are gravitationally bound to other stars. Not that there aren't single stars like the sun out there, but the majority are at least a binary star.
Okay. So what makes that worth studying?
Well, it helps to verify our understanding of, the orbits and the calculations that go into determining these orbits. It's always a tricky question in astronomy. What's the worth? What's the practical, side of it? Kind of hard to answer for that, other than just our knowledge, and we should know how stars work, what the mechanics are, the celestial mechanics. Mm-hmm. So beyond that, partly just, interest, and, being able to make predictions of, where these stars will be at some point in the future or where they've been in the past.
Sometimes
how they're going to evolve.
Sometimes it's just fun to know stuff.
It is, yeah. Yep.
So you yourself are a Keene State graduate, correct?
Correct, yep.
So what brought you back here to teach?
kind of the story is I was working in optics, actually, in the area. Okay, there's a lot of optics companies in the Keene area. And one of the physics professors retired at the time, and they brought in an adjunct from UMass, actually, to teach, to cover, the classes that the retiring professor had been teaching. And what happened is he was supposed to teach some labs, but he had to back out, just before the semester started, just a couple days before. So there wasn't anybody to cover the labs. So the physics professors here knew I was working in the area, and I was on campus from time to time also. So they gave me a call and asked if I could come in and talk to them and see whether I'd be willing to, cover these labs. And I did. And at the same time, kind of funny, not funny, but what happened, there was a physics technician that would do the lab setups. And he actually took a bad fall and injured himself. So I ended up kind of taking on his role at the same time that I was teaching the labs. And so that's sort of where it started. And it kind of evolved over time, and here I am today.
Oh, very cool.
So,
well, not the guy falling and hurting himself, but
no, he ultimately was okay, but it took a couple months for him to get fully back on his feet. So,
did you work with any professors that you had while you were a student?
Yeah, absolutely.
What's that like, going from a student to an more or less equal?
I think it was a slow transition in my mind, feeling that I was an equal on some level over many years. But I think it was a smooth transition.
Good.
Because you're working with them, beforehand, and then it was just kind of a continuation of that, and over time, that.
Very cool. So I've read that you develop many of your own class exercises, and you even go so far as to write your own computer software and design apps for your students. Why go the extra mile like that when there are so many textbooks and exercises already out there?
Okay, one, it's just interesting. And here's kind of my thinking. Although there's a lot of good apps out there, they don't necessarily do exactly what you want them to in the way that you want them to. So if you write your own software, you're learning something yourself, and in the end, it's going to do exactly what you want, at least within your ability to program it, and the computer's ability to do what you want it to do. Mm-hmm. Okay, so I can tailor, custom an app to an activity I'm doing in class to do exactly what I do with the flow that I want and have all the features that I want. Nothing extraneous, and everything I need is there, and everything the students need is there, that they would need is there also. Yep, and I'm constantly writing computer programs. As a matter of fact, I just finished up. I wrote one over the last 9 months for the binary star research, which I'll be implementing within the next year.
Very cool. Is that something you picked up just as a hobby, programming, or do you have any formal training in that?
Well, I've had programming classes. I've had a fair number of them. But really, I consider myself to be a hobbyist, although I can program in a lot of different languages. And I've been programming probably for 30-ish years or so. But I still consider myself a hobbyist. I do it for fun, but there's actual, uses for what I, do for fun and as my hobby here with the students and stuff. And sometimes I have students write some programs in classes or whatever, so try to get them involved sometimes too with simple programs. Sometimes I've done it in an electronics class, and a few times I've had student projects in astronomy where I've had students write programs for me. So,
Oh, cool.
yeah.
This is a very productive hobby.
It is, and it goes well with astronomy because it's called computational astronomy, where you solve astronomy problems using computers. So,
Very cool. So you said that app that you've just finished developing is going to be used for binary stars. What exactly is the app looking to do?
okay. One of the things that is difficult about binary stars is when you look at them, they're close together, and you want to measure the separation. That's one of the key things. There's three key things of interest to me about binary stars and a lot of people studying binary stars. It's the date of the measurement, which is obvious, easy to get, how far apart they are, not necessarily easy to get, in the position relative to one another in the sky. The big thing in measuring binary stars is measuring close binary stars and stars that have large brightness differences. Very hard to do. What this software does is you can take a picture of a very close binary star that the telescope can't resolve or split. The telescope and camera see it as one star. I take an image. I take the data from that image and I dump it into this program. This program can not only tell that there's two stars, it can actually measure how far apart they actually are, which is one of the things that can be used to determine the orbits. There's actually quite a few different elements that you use to determine the orbits, but like I say, those are the three things I'm interested in.
Is that something does software that you have created get used elsewhere, or does it stay just within Keene State?
Probably 99% of the time, it stays within Keene State. Trying to think. There may be a couple times that I've given software to somebody that I know in astronomy or whatever that I've written that they use for something. And I once wrote a carpentry program, believe it or not, maybe about 15, 20 years ago, which I gave to somebody so that they could figure out like rises and runs for roofs when they were building roofs. But yeah, generally everything stays within Keene State.
Oh, cool. Are you a carpenter yourself, or is that just a gift for somebody?
At the time I was doing construction, I was working for the guy. So, so I used to, during the summer, do things like, I don't consider myself a carpenter, but I would, work for a carpenter, and I always consider myself as a board holder. As the second person, I'd hold the, there's a power end to a tape measure, and then there's the other end, and I was always holding the other end for the for the true carpenter.
That's about where my skill level sits too.
Yeah. So.
All right. So as we come to a close here, is there anything you'd like to add?
Well, I can give you a quick rundown of things to look for in the night sky.
Absolutely.
Okay, so we just came off the harvest moon, 2 days ago, and it's still sort of a harvest moon. It's really the full moon, closest to the first day of fall, which today is the first day of fall, the nocturnal equinox.
That's right.
Okay. So in terms of planets in the evening, I would look to the southwest to look for the brightest star in twilight, and when it's first getting dark, the brightest star is the planet Venus. If you look to the southeast, the bright star in the southeast is the planet Jupiter. And let it get a little bit darker and look in the southeast direction. You will see a star to the right of Jupiter, a little bit higher up. That's the planet Saturn. So 3 planets are pretty easy to find in the evening this time of year. And then maybe the last thing I'll mention is not so much astronomy, but it is related to astronomy, it's technology. The James Webb Space Telescope, which is going to sort of be the successor to the Hubble. It's not really replacing Hubble, but in addition to the Hubble. That's going to be launched in the near future, maybe as early as November. Cool. So I would, in the news, keep an eye on that, because Hubble gave us all these wonderful pictures. Well, the James Webb will give us even more wonderful pictures, in the coming next couple of years, and it's due for launch in November if all goes well.
Oh, very cool. I had not heard about that. That's awesome. All right. Final question, Keith. Do you have any advice for people interested in astronomy or astrophotography but don't know where to start?
Specifically just in general or here at Keene State, or?
Either or.
Okay. If you're interested in astronomy, get out there and start looking. Get out there, start looking with your eyes. There's a lot of good apps on the web. There are also good books that you can read, probably not as common today, and just get out there, start looking, learning the constellations, and then I would get a pair of binoculars. And binoculars, sometimes people are like, I want a telescope. Well, I use binoculars just as much as I use a telescope, believe it or not. So they're a good instrument even after you get a telescope. And then if you're doing that, then step up to a telescope, in a year or whatever. And, just little by little, learn those constellations, learn those stars. If you're interested in astrophotography, I would do the same thing. You're not going to get too many great pictures if you don't know where to point that camera. So, start getting out there, get a star map, read some books, look at the web, start learning the basic constellations, stars, and you can take pictures with a camera on a tripod. You don't even need a telescope. Be patient. And then a little bit down the road when you do get that telescope, you can start trying to take pictures through the eyepiece. And then eventually you can progress to more complex ways of taking pictures like the ones you saw. You attach the camera, take out the eyepiece, and attach the camera directly to the telescope. Essentially, the telescope becomes the camera becomes the eyepiece, or the camera basically becomes the lens, or the telescope becomes the lens to the camera, essentially.
Yeah, very cool.
But start out slow and take steps, but get out there and start observing and start taking pictures.
All right, excellent. Well, thank you very much, Keith. It's been a pleasure. Well, that's the end of our episode. Thanks for stopping by.
Okay, well, thanks for having me.
Absolutely. Thank you for listening to The Chirp. Music provided by composer Nathaniel Bridges. See you next time.